Hello everybody, welcome to our channel Full Stack Developer, the channel that will boost your productivity as a full stack developer. Why your API should be resilient? Every backend programmer should know the answer of this question. Imagine that we are working in a microservices environment and we want to get customer bills. Our HTTP request will pass through multiple services to get the data. But sometimes the path can be messy and one of the services can fail to respond for a reason or another. But what we can do in this case? This is where resilient patterns can be useful. Let's start with the first solution, which is retry policy. In this case, when our HTTP request fails, we try another call and fortunately we get a response. Of course, we can limit the number of retries. We can choose, for example, a maximum of 3 retries before we respond fail to the client, or put some wait time between these retries in order to let the server recover. Let's see this in code. Before we start, let's install some nuggets. Let's now add an HTTP client to our server. Now, in order to use retry policy, we will just add a transient HTTP error policy here, and then we are going to call wait and retry async, and then what we are going to say is that we are going to retry 3 times, and then between each retry we will put some time here. Here in execution we will have the first retry in 2 seconds, the second one in 4 seconds, and the last one in 6 seconds. The second policy is circuit breaker. So with this policy, if you are getting a certain amount of errors, we are going to give the system a break so it can recover. So when we have many errors like this, we are going to block all calls for a period amount of time, giving the chance for the server to recover. Let's see this in code. So here I'm going to add a transient HTTP error policy, and then I'm going just to call the circuit breaker async. So here the first parameter will be the number of errors that we are getting in a short amount of times. Let's say that we want them to be 10, and then the second parameter is the time for our server to break and recover. So here I'm going to say that I want my server to be down for 60 seconds, for example. So let's now move to the next policy, which is timeout. So we are not going to let the client wait forever for a response. We are going just to cut the connection if the execution time is very long. Let's see this in code. So here we're going to add the policy handler, and then I'm going to set my timeout here. And here I'm going to say that I want a timeout of 10 seconds. Otherwise, we throw. The next policy is rate limit. With this policy, we are going to constrain execution to not exceed a certain rate. This can be useful if you have a database, for example, that can't handle 1000 queries per second. So limiting the speed can save us a lot of bugs, especially when we have limited resources. Let's see this in code. So here I'm going to add a policy handler, and I'm going to call the rate limit async. And in parameters, well, I'm going to say that I want 500 execution per second. In this way, my database can stay safe. The next policy is cache. This policy is the most used with Poly in production because it offers caching data for a period of time to avoid calculating something that doesn't frequently change. To see this in an example, we assume that we have this call that run through multiple services. Instead of calling a service that doesn't frequently change, we can cache its data for a period of time. Let's see this in code. To use cache, we have to create a memory cache provider. For this, I'm going firstly to add a memory cache. Let's now add the policy handler. And then I'm going to pass my cache provider. And the second parameter, I'm going to pass the time that my data can be cached before it will be updated. So here I'm going to say that I want my data to be cached for 5 minutes, for example. The next policy is fallback. This policy defines an alternative value to be returned or action to be executed on failure. To give an example, if a service doesn't respond, we can make it return the fallback data. Let's see this in code. So here I'm going to add a transient HTTP error policy. And then I'm going to call the fallback async. In parameters, I'm going to put data that will be returned in fallback. So here I'm going just to put that I want an empty response to be returned here. Last policy is bulkhead isolation. So one fault shouldn't sink the whole ship. So here, if we have a service that do very intensive CPU operations, we can isolate it and limit its actions so it doesn't bring down the host or causing cascading failures upstream. So for example, we can isolate this service and limit its concurrent actions or limit actions waiting for an execution slot in the bulkhead. Let's see this in code. So here I'm going to add a policy handler, and then I'm going to call the bulkhead async. In the parameters, I'm going to say that I want only 12 concurrent execution to be in the same time. That's it. So I hope that you liked this video. See you in the next ones. Ciao.